What was old is new again. The rotary engine gets a second life. And in Italy, a devastating bridge collapse inspires innovative thinking for a new one. That's This Week in Engineering. Today's episode is brought to you by Engineering.com, the world's trusted source for engineering content. Check out this and many other videos on Engineering.com/TV today. The auto industry, well, it's shifting away from the 150-year-old internal combustion engine toward electric vehicles. But Alex 𝗘𝗡𝗚𝗡𝗚, founder and president of Liquid Piston, based in Bloomfield, Connecticut, well, he says EVs are missing a key component, a rotary engine. 𝗘𝗚𝗚𝗡𝗚𝗡 has three arguments. First, he says, most EV drivers plug into the grid, which burns a lot of fossil fuel. Second, he says, a 1,200-pound battery, well, it just isn't necessary because a typical driver they'll rarely go the full range of an EV. Most trips are between 5 to 15 miles. For the times when more range is required, a small, compact, efficient rotary engine can make up the difference. Otherwise, he claims, you're driving around your battery. Here are some of the benefits of the rotary engine as reinvented by Liquid Piston. It operates well on hydrogen. It doesn't have the glowing hotspots in the engine common to internal combustion engine designs. Now, the company is aiming to make a zero-emission hydrogen-powered rotary engine. The rotary can be 30% more efficient than a conventional ICE or diesel engine in this application, and it can rev higher up to 13,000 RPM, and without the reciprocating mass of pistons, it can run smoother. It also has far fewer internal parts, so it's more reliable and cheaper to produce. We're calling it the rotary engine, but it's a Wankel engine, first patented in 1929. But until now, it had practically disappeared from view. Now, Mazda installed one in the RX-7 sports car in 1986 and NSU before that, but they abandoned it in 2002. This time around, Liquid Piston's rotary engine has apex seals that are stationary in the housing rather than in the rotor. Now, it runs at higher pressure and higher efficiency compared to the original Wankel design. It shines in power-to-weight ratio, making it attractive for sports cars or aircraft. Without that oscillating motion, it can reach much higher speeds, and speed is power. Liquid Piston built 4 generations of engine architecture and finally converged on what they call their X engine. They've received a small business innovation research contract to develop the X engine for a hybrid electric propulsion system for unmanned aircraft. The company's also been chosen as one of 12 winners of the U.S. Army's X-Tech Search 3.0. It will configure the X engine as an auxiliary power unit or APU. The company has 41 patents with 23 pending. More to come on this refreshed technology. Completed in 1967 in Genoa, Italy, the Morandi Bridge was designed to bypass the city and enable traffic to cross the Polsevera River. It became a modern wonder, but it was ultimately plagued with structural issues that led to a devastating collapse and the need to rebuild. The finished structure was a 3,878-foot bridge that was 148 feet high at road level, featuring 300-foot towers. It had a maximum span of 690 feet. On the morning of August 14, 2018, heavy storms blew through Genoa, and one of the 50-year-old bridge's cable stays broke, taking down a supporting tower, a 690-foot bridge section, and vehicles along with it onto the city streets below. Although the collapse was tragic, the bridge was a vital part of Genoa's infrastructure. Now, shortly afterward, it was announced that this old bridge would be torn down and a new one would be built. Just 18 months after the demolition of the original bridge, a new bridge was inaugurated. Architect Renzo Piano, a Genoa native, he was selected to design the new bridge. 𝗘𝗡𝗚𝗚𝗚𝗚, an engineering firm, was chosen to see that the design came to fruition. The 3,500-foot urban bridge has a steel deck with 1,931-foot spans, 18 reinforced concrete piers, and 2 adjacent piers, as well as metal fins on the sides with 2 rows of solar panels. The aesthetic of the design pays tribute to Genoa's maritime history. The deck is reminiscent of a ship's hull. The construction was driven by innovative technology. Each step involved the use of Bentley building information modeling to provide a digital twin for every component, including the terrain, route, road, steel, and concrete structures, as well as the mechanical and electrical subsystems. The technology helped reduce costs, enhance collaboration, and provide more accurate calculations. The process started with taking a laser scanner on a flight over the area. Now, these scans provided details that could be digitally reconstructed into a 3D surface of the bedrock, enabling precise depth measurements required for the foundation piles. Templates are made for the placement of components both small and large. Each required a data set with information on physical elements and the construction schedule, as well as dimensions, volume, and other vital factors. From the photovoltaic system to the dehumidification system and metal structures, the digital twins helped ensure that compatibility between systems, precise positioning components, and maintenance for auxiliary systems would be easier. It even allowed for the simulation of airflow inside the deck, which helped determine how many units were needed. As other vital bridges and structures begin to show their age or weakness, the Morandi Bridge will continue to serve as a reminder that not everything was built to last. But with innovative engineering applied to building new structures, they could last longer and be safer. That's it for this week's show. Thanks for watching.